Welcome back to another video. In today's video, we're going to talk about pivoting on Windows Active Directory. Previously, we talked about pivoting on Linux, and we saw that using SSH, local port forwarding, and remote port forwarding have enabled us to communicate with other Linux machines that may reside on other networks. You can visit my video on Docker exploitation. We talked about pivoting on Dockers. At the same time, the concepts can be applied in general or in general pivoting. Now, how about Windows? What is the actual case? What is the actual scenario that we can go through if you want to do pivoting on Windows? So I created this scenario here, and the best perfect practical machine I found on the internet was HackTheBox Fulcrum. This is you here. It appears like 4, right? Fulcrum. So this machine, you can find it on HackTheBox. It best demonstrates the concept of pivoting on Windows Active Directory machines. So what happened? So basically, we have our attacker machine from which we do the testing all the time. We got access to a Windows machine. The Windows machine actually resides on, say, a network such as 10, 10, 10, 0. This is, for example, right? Not the actual real network address. Now we got access to Windows machine by sort of web exploitation. So we landed some sort of shell, right? Okay. Now, once we were on the Windows machine, we found that there were other machines on the network, on different network. So the Windows machine resides on a network which is totally different from this network here. So the other network contains web server machine and file server machine and domain controller machine. All of these machines are part of a domain. The main domain controller machine is here, and they're all connected through the domain. But the thing is, these machines are actually located on a different network. I call it the AD network. So this is the AD network, the Active Directory network, and it's totally separate from the Windows machine network. So say you can call it here like 172.16.0.0 here. So as far as this machine is concerned, we are fine. We got foothold on the machine through the exploitation, right? And specifically in the machine HackTheBox Fulcrum, it was XXE exploitation. We exploited XML vulnerability in JSON. All right, so that's not the topic of this video. We're going to demonstrate that when we get into the practical part. More importantly now, how do we interact with these machines from our attacker box? Yes, the solution is to use pivoting or port forwarding. So from here, for Windows machine, we apply port forwarding, okay, so that all connections that come on the Windows machine say on specific port. So we pick up a port, such as, say, the port we selected on the machine was 62015. Okay, now we make the Windows machine listens on this port, and we create a rule such that the connections coming to this port will be forwarded into this machine. The first machine is the web server machine. So from port 6205, we port forward here. Oops. Okay, no problem. From 6205, we port forward from this port on another port on this machine. Now, the selection of this port on the web server machine depends heavily on what kind of open ports on the web server machine are open. We found that there is the WinRM port, the Windows instrumentation port open on this machine, right? So we forward from 6205, okay, into this port. Now from my attacker machine here, what I do, I connect to this port, okay, 62015, and the port forwarding rule I created on Windows machine will take care of the rest. Will forward my connection from 6205 to the WinRM port on the web server machine. That's how I can interact now with the internal network, okay, from my attacker machine. And once I am here, I will be able to pivot to these machines easily, right? No need to create any other port forwarding rules. Again, it's only one to get us inside the network. Once we are inside the network, we can pivot freely from the web server machine to file server machine, and from file server hopefully to the domain controller. That's the main process. Now, what to use if you want to do port forwarding on Windows? There are several methods actually. The first one, we can use plink. Okay. The other method, we can use socat. The method I use in this video, and the one that worked for all people who did this machine, it is with socat. Now, you may need to use plink in other scenarios. That entirely depends on what works for you. So now we talked about the theory. Let's now jump to the practical scenario. Okay, let's close the board. All right. So this is the nmap scan running. I'm gonna skip this part, but we'll keep this running so that if we need to come back to it, we're gonna be able to do that. So let's now copy the machine IP address, and I'm gonna directly, guys, browse to the ports that were open. You can do the nmap scan on your own, and you can find these ports as they are. So the first port, it was 4. If you navigate to this port, you will see that the machine will see that the page displaying the machine is under maintenance. Click on try again. It takes you to another page, but as you can see, the display or the contents of the page stay the same, but the URL changed. Take a look at this: index.php, and the URL parameter page equal home. This hints to a file inclusion vulnerability, local file inclusion vulnerability. But we're not gonna be able now to do anything with this vulnerability. Now we'll keep this as a note, and we will get back to it later. So the other port that is open on the machine is, of course, we can access it through the web. It is 56423. Enable to connect. Let's see why. Is it a proxy? We have 6 here. So we remove the 6. 54. So 56423. Let's see this. Now it worked. As you can see, we received a JSON response. Ping pong. Heartbeat ping pong. This is a JSON response. Now, in JSON, we can also exploit, or we can also look for if there is XML vulnerability on the JSON site. In this page, it lays down how to play, as you can see, how to play with the content type in order to exploit XSE on JSON endpoints. So here is, you can see all of the details. Basically, what we're gonna do, we're gonna play with the, we're gonna make a post request, all right? And to post request, what we will do, we're gonna change the content type from JSON into XML. And in the payload, instead of sending a JSON payload, we will be sending an XML payload. That's how we will exploit this vulnerability. Here you see an example. As you can see, the post request sent to the vulnerable page. The content type has been changed to application/XML, and instead of the JSON payload or the JSON whatever content, we did actually display an XML payload, right? The XML payload reads the contents of the password file, and that's exactly what we will be doing. Remember that when we accessed the machine on port 4, there was a file inclusion vulnerability. We suspect, of course, that there is a file inclusion, but it's a candidate for file inclusion vulnerability. Now, what does this mean? It means that if we craft an XSE payload, so what it does, the XSE payload, it will download, say, a PHP reversal from my machine, all right? Once it downloads the PHP reversal, I want to execute this. How do I execute this? I will use local file inclusion in here. I'm going to include it in here. Local file or remote file inclusion. So what's going to happen now, the XXE payload, instead of this one, I'm going to use this URL, and instead of the home, I will assign the value of, or the path to the shell on my web server. That's how we will be able to exploit this vulnerability and get the first foothold. Okay, back to work. Nmap scan is finished. As you can see, these are the open ports. We have 4. We discovered this one. We discovered other ones. We navigated through this one, Now the other ones are 80, 88, 22, and 999. All right. So what is the next step? Next step is to navigate to the machine directory I created. Not clear. Okay. So curl. So this is how we will send the payload. We will use curl, right? And we define the URL. The URL is the machine IP address along with the ports. -x to specify the request, the HTB request type, it is post, and he will specify the data. As you can see, this is the XXE payload. Let's go over the payload step by step. It's easier to go over the payload here. So XXE, let's see. Yeah, XXE against JSON. So this is your payload. By the way, you can send the post request also in perp. Okay, you can make the post request with a page and use perp if it is easier for you. Let's go over the payload. So first we define the version of the XML, the encoding, no brainer. Next we define doc type. In this, since this is a test payload, for the purpose of taking notes, I named it as test, but of course you can name it whatever you want. Next we define the entity that will hold the payload. In my case, I used the etc password, right, to read the content of the password file. Now, but the structure is the same. In here we define, or we put the payload you want, whatever you want. Next, we define root element. It's very important for any XXE, any XML payload to contain the root element. Without the root element, it's not gonna work. Define the root elements, and then here, search name, and in the value, you can type here, you can mention, or you can call the entity we created, which contains the payload. We can call it by adding ampersand and the name of the entity along with the semicolon. Let's go back here. So this is our payload, right? Now I call it hack, and the entity we name it entity XXE. So here I read, let's see this one. Yeah, so what happens here, instead of reading the contents of the password file, after system I define the payload as such. I browse to the machine IP address, in this case it's localhost, since it's viewed from the perspective of the machine itself. And port 4, the port 4 is the one that is suspected to contain the inclusion vulnerability. Index PHP page equal. Now in here I include the path to shell. The shell is a PHP reverse shell that I will host on my web server, right? Now what's gonna happen now, once I send this payload, the machine on 10.10.10.6.2 will perform a call to this URL and download and execute the shell. Okay, so let's open the web server. Sudo python now the PHP reversal, take a note that the PHP reversal listens on port or opens port 4545 on my machine. So I'm gonna need now to open the listener to receive the incoming connection, hopefully. nc-lvp 4545. So once I hit enter, it's supposed to work. Ping pong. It means we haven't, look at here, we haven't received the request. So this means something has changed. I'm gonna need to take a look at my IP address. Is it correct? The IP address has changed. So it is 3 instead of 2. I'm gonna keep this running, but in the payload we will modify the IP part. Instead of 2, I'm gonna put here 3. And we get back to the listener, refire the listener here, and execute the payload. As you can see, the file has been requested. Let's take a look here, but we haven't received anything. We received ping pong get shell.php. This means that the shell itself has the wrong parameters. So let's check the shell out. This is a regular PHP reverse shell. As you can see, the IP is different. Now here we put 3, and now hopefully it's gonna work. Okay, resend the payload. Now we receive the first foothold. Now from this point on, we will discover what is the machine we are on, and then we perform the pivoting. All right, so let's see who we are first. ID, and we are the dub data. All right, so pwd, we are at slash. This is the okay. So now let's see if there is a directory called var ls. Yeah, there is cd dub. So here is the web directory. So we go to HTML. Nothing in the HTML. Let's go back. Let's go to uploads. There you go. There is the home, the index, and the upload PHP. Now there is one interesting script, fulcrum upload to corp.ps1. If we cat this one, taking a look at the contents of the script. Let's see here. So sudo forward the partial remoting port to the external interface. Password is now encrypted. Now this is a variable called 1, and the value is web user. Here is 2, and we have 3, base64 4, takes 3, all right, which is this one, the base64 value, and convert to secure string dash key 2. So it's kind of encrypting the password. So it's actually this script is designed to create an encrypted password using the convert to string. Finally, new object system management automation, PS credential 1.4. The 1 is the web user and 4 is the encrypted password. So basically what it does, it creates encrypted passwords up to this point. Next, what we are doing here, we are creating a credential using the PS credential. The unique feature of PS credential is that once you create a credential and assign it to a variable, let's say 5, you can now use 5 in whatever commands you want that require authentication. This is an example invoke command dash computer upload fulcrum.local. Now this is clearly you see part of domain dash credential 5 dash file data to ps1. So in order to connect to the computer upload here, right, with this file, we have to define the credential. Since we use the method ps credential, we can just mention the variable 5, and it will automatically recognize the username and the password, which are web user and the encrypted password that is stored in the variable 4. That's the feature of PS credential. Okay, so what is in this for us? We got how the script working. What do we do now? So basically, from PS credential, we can revert the password and get the original form using get network credential. Let's see how this works. So let's copy the script now to our local machine and try to get the password. So the script is here, I guess. Let's see what it is. So cat PowerShell. This is the script which I have copied previously. Now, if you execute the script here using bwsh to launch PowerShell in Kali and the name of the script, once you execute that, as you can see, it gives you the password. So what happened? As you can see, I added one line. Take a look at this. This line is taking the credential 5, right, stored in the variable 5, and uses the get network credential method, which is used just to get the password back to its original form using the cmdelete password. And that's how now we managed to decrypt the password. Actually, we didn't decrypt the password, we just restored the password to its original form. It is not decryption. I'm not going to call it decryption. We just use the method get network credential along with the password cmdelete to get the password stored in the 5 variable that was formed here. And note that if you want to use the get network credential method to restore passwords to its original form, you're gonna make sure that, or you need to make sure that the password has been encrypted with the method ps credential. If it wasn't encrypted this method, it means you can't restore it with get network credential. You may need to use get credential, which requires interaction with the GUI interface. All right, let's not confuse now with all and not dig deep into non-relevant stuff in this video. Now that's how the script works, and that's how we restore the password. Now take a note that we now have username, web user, and password. So what's the actual use of these two? All right, so we're gonna get to that. If we go now to the back to the machine here. Okay, so now if we type ifconfig to see the configurations of the machine, let's take a look. So we have various network interfaces, many network interfaces. We have the corp, we have ins32, which is the current one. The loopback, that's fine, but take a look at this, VIRBR0, and this is a different network IP address, which means back to the introduction of the video, there is another network that resides on this or uses this IP address. So you want to find out what is this network here. So what do? We're going to perform an nmap scan. So let's go to temp, and again, my machine has the web server open on port 8000, and I have the nmap binary downloaded to my web server directory at Fulcrum. You can find this, but you can copy this binary from your local Kali machine or download it from the internet. Make sure it's the correct one. Going back here, I'm gonna say wget HTB, retrieve the nmap from there, 14.3, and then 8000 nmap. So right now we have retrieved the nmap from our machine. Let's now do an nmap scan on the entire network. Which network? The network that we have found here, the 9.192.168.122.1. Now, scanning the whole network is actually useful if you want to reveal what are the live hosts on this network. But this won't be enough, as we will see also the open ports on each of the machines on this network. So let's take this IP address and scan it. See what are the hosts on here. First, we have to define what is the subnet mask. It is 255.255.0, which means the CIDR is /24. So we go back and ls, so chmod, give nmap execution permissions. Okay, nmap now dash data dir nmap. We use this actually to mimic the scan process as if we were doing it from the attacking box or my Kali box, and then we scan the network. Paste the IP /24. Now we're going to need to find what are the live hosts on the network. Now there is another method actually to just jump directly to the IP address of the machine or the machines that reside on this network instead of using nmap. We can also use the ARP table. So the nmap scan has finished. As you can see, we have two live hosts. The first one is 192.168.122.1. These are the open ports. As you can see, we have Kerberos Active Directory. And lastly, we have this one. Take a look at this. Ends with 228. And these are the open ports. So our focus and concentration now will go toward this one. Okay, this is the next machine that we need to pivot into. Before just firing the socket listener, we're going to need to find if there are more open ports on this machine. So again, issue the nmap scan one more time. But we will scan for all the ports on this machine. Hopefully this won't take much time. Alright, so from the Nmap scan results, we see one more port has been discovered, 5986. This is for the Windows management instrumentation that is used for PowerShell remoting. So what does this mean, guys? It means we can now use WinRM to log in directly to the machine on IP address that ends with 228. But remember that we cannot do that from our attacking box from here, since this machine resides on a totally different network than the network we have just compromised on this machine. So what we're gonna do, we're gonna now perform pivoting or port forwarding using SOCAT. So let's see now where I can see the SOCAT. SOCAT. Using SOCAT. What is using SOCAT? Let's take a look. NetSH. So this is lateral movement. All right. Let's see SOCAT now. It has to offer. So first, we create the forwarding rule. As you can see, we define the port on which the machine will listen, the compromised machine, of course, and we'll define the IP address of the other machine which we would like to access on this port. So let's copy that. Oh, first we have to copy SOCAT on the compromised machine. So pwd we are at temp ls, see if we have it. We don't have it. Let's now use my web server 14.3 8000 / SOCAT. SOCAT cannot be found. ls, I have SOCAT here. What's the problem? Oh, it is the wget, guys. Oh my goodness, how can one forget this? So paste. Now we have SOCAT. Let's go back to my notes and copy this. I'm gonna use the same port. I'm gonna copy up until this point where I need to define the IP address since it is different. Alright, so IP address is 192.168.122.228, right? Let me see. Yes, it's correct. And lastly, do we have anything else to define? Nope, it's the %. What happens here? Remember that we are at the compromised machine now. We are opening a port 6033, right? This machine or the compromised machine is now listening on this port. Any incoming connections on this port will be forwarded to the machine that we would like to access. Okay. Now I forgot to put the port that we would like to access. In this case, since we want to interact with the Windows instrumentation port or partial remoting, the port that we would like to interact with is 5986. So 5986. And that's it. So directly now we can interact with the port WinRM. Permission denied. Thank you very much. chmod +x SOCAT. Alright, now it's ready. All we have to do now is to send connections on port 60323s and it will be forwarded to port 5986. Remember that 5986 is the WinRM port, which means we will be ending up interacting with PowerShell. So this needs to be done from a Windows machine, right? But an alternative way is to use Ruby, okay, the Ruby language. We can create a Ruby script. Inside the Ruby script, we can put PowerShell commands. So there is a script I found on the internet, as you can see here. It's authored by a user called Element on GitHub. This is the script, WinRM shell with upload. If you take a look at this script, we need to define the IP and the port. The IP and the port of what? Of the machine we have compromised and the port it's listening on. Username and password. This is authentication. It assumes that you have authentication information to access the PowerShell remoting. If you remember, we got access to these credentials, web user and M4NG, right? This is the password. We can use this credential, guys, and supply them here in the username and password. Next, we are now, as you can see, using the WinRM to interact with the machine we are targeting, which happens to be the machine on 192.168.122.228. All right. So the script has already been created at my local directory. Let's see here. This is nmap, revert shell, PowerShell. Let me take a look at this one. Cat script rb. Yeah, this is the script. Let's now make slight modification on the script. So instead of 60217, I'm gonna type the port that I created as a listener port, 6033s. 6033s. These are the correct credentials. And now once we launch the script, guys, using Ruby, it will now interact with the port 5986 and give you PowerShell access or PowerShell remoting. Let's see how this works. So sudo script. Okay, Ruby. All right. As you can see, we get now PowerShell access. Now this PowerShell access or PowerShell remoting has been facilitated by the fact that there is the corresponding open port or the corresponding port on the target machine open. If this wasn't open, we cannot get to this, right? So take a note that now we are using the WinRM, not reverse shell. This is not a reverse shell. This is the PowerShell remoting access using port 5986, facilitated by the fact that we're using Ruby here. So we don't need to use Windows PowerShell now on my Windows machine. That is how good is this script. Okay, so right now we are where? We are at the web server machine that we talked about earlier in the very first of the video. Right now we are inside the other network. If we type ipconfig, will this work? Let's take a look. Ethernet configuration 192.168.55. Windows IP configuration. This is the Ethernet adapter. I don't know why it is 55. It should be 19122. Anyways, now let's start now enumerating this machine, the web server 1, and see if there is another machine we can pivot into, right? Let's see. So since the name indicates the presence of a web server, we're going to need to navigate to the web server directory on Windows Active Directory or Windows Server. So it's cd c, and we go to init pub /www root. This is the web server directory in Windows servers. Windows Server. There. What do we have in here? We have index and we have webconfig. Enumerating configuration files is important and tremendously helpful when you are doing enumeration on compromised machines, since configuration files may hold plain text credentials. So type web.config. Let's see what are the configurations on this file. Okay. Connection string LDAP dc fulcrum.local. Here we have the main domain fulcrum.local, and here's the domain controller. Next, what do we have? Add name system. All right. Connection string name, public key, connection username, fulcrum LDAP. So this is another machine on the domain controller. We have DC, we have fulcrum, okay, and we have also the web server. Don't forget this. So now we discovered another machine on the Active Directory network. It is fulcrum /LDAP, and this is the password. By the way, this is not the oh my god, this is not the machine name. This is the username, I know, but actually it contains information about the machine name. Now here we have the connection password. So what does this mean, guys? It means now we can create now, or we can pivot to this machine using also WinRM. Before doing so, let's now execute a couple LDAP queries to get more information about the domain controller and this machine here, supposed to be here. So now we execute some LDAP queries to enumerate properties of these two common names. Let's see if I go to Active Directory and search for LDAP PowerShell script for user enumeration. Nope, 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 nope. Executing LDAP queries for data harvest. That is cool. Let's see. Harvesting computer names. Okay, so this is an LDAP query we can execute, guys, defining what is a domain controller. In this case here, we replace domain controller with the fulcrum. Target machine LDAP. The target machine name is fulcrum here, if I'm correct. And we define the target machine password. It's already here. And then we display the properties. All right, let's take this one. Before taking that one, let me modify on it here on my notes. So domain controller will be replaced with fulcrum. Target machine will be also fulcrum. Target machine password will be this one. Let's see. Let's now execute this query. See what it can yield. Displaying the properties about these two. So we have two common names, DC, the domain controller, and file. That's the common name of the other machine. That's fine. Now, let's see if we can harvest other information. So again, we replace the fulcrum with the domain controller name, or let's just copy that. I don't want to mess up with the original one. So copy that. We have this. Target machine. And the password. Where is the password? There you go. Alright, let's now find all of the properties and information about these two common names. What is that? Let's see. Let's start from the very first. Name, value. Okay. Common name. Description. Name, Bobby tables. Bad, password time. Info, password set to. File saver log on. Okay. That's the password for what? Let's scroll down. CM Bobby tables. SAM account name. B tables. That's the machine which has the common name file. I suppose this is the file saver machine. That is the username. Okay, and that's supposed to be the password. So now here we go. You have the login information for what? For the file saver machine, which resides as ptable at fulcrum.local as the username, and this as the password. So what's gonna happen now? We're gonna need to pivot to this machine somehow. All right, so we can actually use the same method. We can go back, we can go to our Ruby script and modify the script a bit to return a reverse shell. Now, if you remember that, if you go back to the machine, to the nmap scan, you can see there is the port 53 open. So we can actually make call outs from the web server, the file server machine, this one, to connect back to us. What's gonna happen now? Let me tell you what's gonna happen. Let's go to another tab. Okay. So ls, this script here, we can modify it a bit. This is the modified version. Let me take a look at the modified version. So this is the contents of the script version 2. Again, we are forwarding the connections on port 60333 in order to access other machines. And we're using the same credentials we have discovered at the very first of the video. Okay. Next, what we are doing here, instead of opening a PowerShell remoting, since we have one session here that uses PowerShell remoting on Windows Instrumentation port, we cannot just create another one. we can only use one. That's why we need another method to access the machine on or the file server machine, which has the common name file. Okay, file.fulcrum.local. This machine needs to be accessed in another method in order to maintain this session here at the web server machine. If you don't want to keep the current connection to the web server machine, you can just cut it out and modify the script with the credentials we have just obtained, which are btables, and this is the password, and make now another PowerShell remoting connection to the web server machine, to the file server machine. But if you want to keep this connection, we're gonna need to use another method. So the method here is like that. So what happens here, I prefer if we open this in the file editor in order to have a full view of the script. Desktop, Fulcrum, and we take a look at this mousepad. Okay, way better. This is for the forwarding. And next, what do we do here? We create now a connection. Now in the connection, first we create a variable called password. The password contains or takes the password you have just found for the file server and converts it into a secure string. All right. Next, we create a credential using the PS credential method, and we specify an argument list. The argument list is actually the connection information. First, we have the username, btables. Okay, and next we have the password. Oops. The password, actually we only need to mention the variable since we have defined the variable at the very first. It contains the password in a secure string. Now we have defined the credentials. We can now use the invoke command to what? You know what? To just let the machine call out or perform call out or reversal. So we specify the computer name, it's file, since this is the common name we have found. Dash credential, cred. The cred is actually the variable that stores the credential, both username and password. And the port is 5985, Windows instrumentation port. And in here, in the script log, the content is the reversal itself. We connect to my machine on port 53. Let's do this. Save. Yeah, we don't need to save. I haven't made any changes. So, okay. So now, this is the web server machine. I'm confused. This is the original machine we have compromised. Fine. Web server machine. Let's now stop the web server and open the port, or use sudo. Actually, we need to use sudo credential in order to be able to open a port below than 1027. So here it is. Now we listen on incoming connections on port 53. Get back. Now we execute the script. Ruby script v2, and hopefully it will work. Hopefully. I hope. If it didn't work, we may need to stop all of this. We received the connection, that's fine. ID. So right now we are at the btable user. Who am I? Right now we are fulcrum /tables, totally different user. This is the file server machine. This is the web server machine. We successfully performed the pivoting. The last step is to perform pivoting to the domain controller. Okay, now if we get back to the nmap scan we performed from the compromised machine, remember that these were the open ports: 4, 22, 53, 80, and 88. So the domain controller machine must have the net log on share open. Okay, now the net log on share open is a share on the Windows domain controller machine that contains log on scripts and other executables. It's very useful if you enumerate this, but how to access that from the file server machine? We're gonna need to use also, I'm gonna call it partial pivoting, right? So in this case, I'm gonna see where I can find the correct command because I cannot memorize commands. Let me search for net log on. accessing netlog on share on Windows DC. I need the command netuse, specify the domain controller, netlog on, user name and password. So let's see this. Net use domain controller name is dc.fulcrum dot local net log on. Okay, user. So user domain name backslash username. Domain name is fulcrum.local, I remember. So fulcrum backslash domain name username. Username is btables, guys. It's btables. It's here. So b. And lastly, we need to define the password. The password of what? The password of the machine we have just pivoted to. So let me see where there is the password in here. This is the password. The command completed successfully. Okay, let's see now if we can access the netlog on here. cd Microsoft PowerShell file system DC. So successfully we access the netlog on dir. Look, we have several scripts here. Since netlog on contains information or contains the scripts and executables for the login, these are the scripts. Actually, if we enumerate them or we take a look at one of them, we can actually get an idea of what happens what happens in the login process, and hopefully we reveal credentials. Let's take a look at this one, for example. Yep, copy that, cat or type. All right, map, network drive, user, and password. Here you go. We revealed one username and password. But how do we know these are for the domain controller? Since now the last step is to pivot to domain controller, we need the admin username and the password. Now all of these scripts are similar in content. They both contain username, definition of username and password assigned to the corresponding variable. But how do we know which one is for the domain controller? So basically we need to do scripting here. We need a PowerShell script that iterates through all these scripts, try them against the domain controller machine, and gives us what is the correct pair of credentials. Say nano brute force DC. What do you think? PS1. Alright, so here to define a function, I'm going to call it brute force. It takes two arguments, username and password. So we call the first one user and the next one is pass. Next we define, take another line. What about indentation here? Okay, this is fine. So new object directory services, directory entry, and define the username, user pass ps space name dash ne, and then put that into null. So that's the function. It takes username and two arguments, username and password, and use them for the directory, or prepares them for use in the directory services. Next, we need a for loop here, okay, or a loop. In PowerShell, it's called for each. This loop will iterate through all of the files we have here, these files. So first, let's create a variable called whatever, call it files, and define get child item. Since we need the variable to iterate or to access a list of all the files, we need to use the method get child item. Where will be here. This is the path. We have 4 here. Okay, cancel the 4. And all the files that end with ps1. Next, for each, for the iteration, for each file in files. Okay, now we need to create the list of variables that will hold the value from each attempt. So let's call it first result select string dash path the file. This variable will change, the value of this variable will change every time it handles a different file. So dash pattern. Next we define the pattern of the password. Let's take a look here. So this is the pattern for all of the passwords. You have @fulcrum. This one is constant, and these changes actually. These characters change. This is constant. So some sort of regular expression would solve the problem. So double quotes. Inside double quotes, we open 2 single quotes, and inside the single quotes, we open 2 parentheses, and type here dot star. Okay, next. Here we define the variables of both username and password. Since we use user and password, we're going to use different names. So say user v1. Does it make sense? Okay, take the result, or take the variable result from the first query and do some matches. The first index, groups, 1 here, and lastly value. So the next one is kind of similar. I'm going to copy that, and here change the index to 1. This one needs to be pass. Lastly, perform an if condition. Okay, in the if condition, in the conditional statement, we will now try the credentials we have grabbed from the first file or from the files against the domain controller. If they work, we're going to display them back to the stood out. So if we call the function br fulcrum local, and then we have first user v1, first argument. Wait, so we have user v1 here. It will replace the argument user, if I'm correct. Okay, that's fine. Next we have the next argument, which is pass v1, which will be the corresponds to the pass argument in the function. So pass v1. How many parentheses do we have in here? So 1. Okay. Next, echo fulcrum. I'm gonna copy this one. It's way better. So user v1 and pass v1. We echo out the username and password if they are correct. That's the script. Now you can take all the script, guys, and make it as a one-liner. Okay, I paused the video to finish pasting the command in here, and now it's running. Now in a separate part, in a separate tab here, I'm going to assume that we will get the username and password for the domain controller. Next, we have 2 options. The first one you can modify on the script v2. Let's take a look at the script v2. What you can do here, we can keep these as they are, but modify on the line here. And instead of this password, we're going to put the password that we will get from the script we have just created. And instead of, we're going to just do the modifications required, the username, the password of the domain controller, and change this to DC, All right, and execute the script. Of course, don't forget to create a listener on port 553, and you will get the reversal on the domain controller. An alternative method is to just flat out get the flag, right? So we can do that easily with one-liner. Let's see where I can find one-liner here. Executing remote commands on a domain machine with their pair of credentials. So we can take this, guys, define the password in a variable called pass, and then define the credential of the domain controller, and then in the script block we can execute whatever we want. Let's take this one. This one needs to be executed from the PowerShell, so we need the session here. We have the script hasn't finished yet, so let me do it from here. Let's first modify it, I guess, because the shell isn't stable. So password convert secure string as plain text, and here is the pass. The password will be, I'm gonna just copy it from my notes, guys. Okay, this is the password for the DC, and then credential. We define the credential, domain name, username. So here we define the domain name. Domain name is Fulcrum, as you know. So fulcrum.local. The username for the DC was 923A, as you will find now once the script finishes. Dash invoke command dash computer name. The computer name goes here. It is DC dot fulcrum dot local. Credential cred, we have it defined here. Dashboard 5985. The script block. The script block here will be displaying out the flag. So cat c users administrator desktop / root text. Let's try this here from the web server machine, see if it works. Didn't work. So as you can see, the script has finished, and here is the username and password, fulcrum local 923A, and this is the password. These are the credentials that worked on the domain controller. Let's now execute now the no, what happened? Execute now this here from the web server machine, see if it worked. Nope. Cat. Nothing happened, I guess, right? One more time. And here is the flag. Now let me try to submit the flag. Submit flag. Difficulty of this machine, I guess it is extremely hard. Yeah, it was extremely hard actually. Submit. Alright guys, so I hope you find the video informative and helpful, and we will definitely see you in the next video.